Hello everyone, welcome to my channel. Today we are going to study the new form of the integral, which is the integration e raised to x in the bracket f of x plus f dash of x dx is equal to e raised to x f of x plus c. Now this is a new form of integral where there are three things. First, it should be exponential function, okay, and in the bracket itself should contain the two functions. First, the original function, and the another one should be the derivative of that function, okay, so that the answer can be directly written as e raised to x f of x plus c. Okay, now let's just jump to the example and see that how we can solve this and how the question looks like. Okay, so let's just take the first example here, where I have I is equal to integration e raised to x and the bracket 1 upon x minus 1 upon x square dx. Okay, now if you just look at the example, this 1 upon x, so the derivative of 1 upon x is nothing but minus 1 upon x square. You should know the differentiation to do this form of integral. Okay, so if you just notice, the derivative of 1 upon x is nothing but minus 1 upon x square. So for that we need to prove. So for that we will consider f of x as 1 upon x, and when you take the derivative it becomes f dash of x is equal to minus 1 upon x square. Then we will write the property, that is e raised to x f of x plus f dash of x dx equals to e raised to f of x plus c. This should be your answer. So in that case, that I will be equal to e raised to x, and what is your f of x? Your f of x is 1 upon x. So this will be 1 upon x plus c. See how simple it is. Okay, it is just you know the property and you have to apply it. That's it. Okay, so this is the simple problem. Let's just take a little complicated one. I is equal to integration e raised to x, then we have upon x also, then we have the bracket x log of x the whole square plus 2 log x bracket close dx. Now the idea is to keep the e raised to x aside, nothing should be with the e raised to x. So here in the denominator of e raised to x we have x, so we have to get rid of that x. So instead of keeping outside, just multiply inside. So it will look like this: x log x the whole square upon x plus 2 log x upon x then dx. Okay, now this x will get cancelled. Now it will look like e raised to x log of x the whole square plus 2 log of x upon x close the bracket then dx. Now let's just consider the one function which is log of x the whole square. Okay, now take the derivative. So if you take the derivative of log x the whole square will be 2 log x, and the derivative of log x is 1 upon x. So basically it is nothing but 2 log x upon x. Okay, that is the same thing that we have got here. Okay, so here we will write the property that e raised to x f of x plus f dash of x dx will be equal to e raised to x f of x plus c. So in our case the I will be equal to e raised to x, and f of x is log of x the whole square plus c. Okay, so this is the second example where it is just look like a difficult one, but it is very simpler if you know how to solve it. Okay, so the only idea is keep the e raised to x aside and take everything inside the bracket. Okay, then solve it, then you will have to identify which function we have to take, so that the derivative should give the another function that is already present. Okay, got it. Now we shall take next one simple problem also. I'll take I is equal to integration e raised to x. Now here there is no e raised to x here. In the question I have cosec and the angle is log x bracket close and another bracket 1 minus cot log x dx. Okay. Now since we don't have e raised to x, so there is one possibility that we might get e raised to x from the log x. Okay. So what we'll do, we'll take log x as a substitution, put log x is equal to t, and here we have a base as e, so that x will give you e raised to t. Okay. Then we'll take derivative, so dx is equal to e raised to t dt. Okay. Then I shall replace this. Okay, so I will give you, instead of dx we can write e raised to t dt, so I'll write e raised to t here and dt here. Okay, and in between we have cosec t and the bracket 1 minus cot t. Okay, hope you understood this. We have replaced log x with t. Now again the idea is to keep e raised to t or e raised to x exponential function aside. So we'll keep this aside and multiply this inside. So that will give you cosec t minus cosec t into cot of t dt. So we'll take the function f of t cosec t. So the derivative of cosec, if you remember, it is nothing but minus cosec t into cot t. Okay, so we know the derivative, right? So we'll write the formula, that is e raised to x f of x plus f dash of x dx is equal to e raised to x f of x plus c. You always have to include this formula. Okay, so in our case I will be equal to e raised to x and f of x, that is in case of variable t we have cosec t, and in case of e raised to x it will be e raised to t. Okay, so I'll write it here as e raised to t then plus c. Okay, so this is your final answer, but also we have to do the resubstitution, so that will be e raised to t. If we can see here, e raised to t can be directly written as x. Okay, from the substitution part, so directly I'll write here as x, and instead of cosec t I will write cosec and log x plus c. So this is your final answer that we got. Okay, hope you understood this problem and also this integral form. Okay, and this form of integral comes for your board exam, so make sure you know this, and it is very simple. You just have to practice little more sums based on this. Okay, if you got any doubt, just let me know in the comment section below, and also if you haven't subscribed my channel, do subscribe and share it with your friends. Thank you so much.